Yeah, good morning, everybody. Good morning, sirs and ma'ams. You're welcome back to class. The end of the thing is always better, as in always glorious than the beginning. Okay. So today we'll be rounding up our discussion on using Python for data analysis. And today we'll be exploring how we can carry out predictive modeling using Python. How we can carry out predictive modeling using Python. So before we go to the demonstration aspects, I will take us through some little background knowledge so as to lay the foundation for the predictive modeling. You know, it requires a little bit of as in programming, but it's not a serious programming. As in with the introduction of AI, it's now easier to learn programming. You know, gone are the days when you want to write a program and you'll be the one to figure out how to solve the problem on your own, and you also figure out how to write the right lines of code. So in this AI-driven era, what we only need is the basic understanding. As in, that's the most important thing we need, the basic understanding. And you agree with me that there are different ways of learning. As in, okay. Under AI, as in there's something we call forward chaining and backward chaining. As in, you can also learn from the solution. As in, you already have the solution to a problem, I want to solve a related problem. So from one solution, you can also learn how to solve your similar problem. That's similar to backward chaining mode of learning. But in forward chaining, as in, you don't know the solution, you don't have the solution at hand, but now you are now working towards the solution. So those are the two ways of learning. You can start from the solution, as in there is no problem we want to solve that has not been solved by someone. That is the fact. There is no problem we want to solve that has not been solved by someone. So if I can Getting it, if I can have the solution used by someone in solving his own problem, if I have the same similar problem, I can still what? Use the same solution. Now, what will be different will now be the, let's say, the data sets work done. For instance, if anybody wants to do any work on sales prediction, many people have worked on sales prediction. What will now be different will be the data sets they worked on and the attributes of those data sets they worked on. So in the first section, I want to introduce us to the basic thing we need to know concerning predictive modeling. Before we start, and predictive modeling is all about making predictions from data. As in, you have an historical data. It will be a weather data. It will be a sales data of a particular company. It will be a disease outbreak data of a particular organization. So now you want to carry out a predictive modeling. That is, you want to use the historical data to make predictions. That's what predictive modeling is all about. Now, Python is a very good programming language you can use for predictive modeling. And the reason why is that Python has rich libraries that has different functions we need to use. Gone are the days when we want to use any machine learning algorithm to carry out any machine learning task. You have to write the code on your own. But nowadays, Python has different packages. So what you only need to do is to call respective machine learning algorithms you need for your machine learning task. So now let's quickly go through this slide. So predictive modeling is used to what? Determine a certain output using what? The historical data. For instance, you can have a data set that contains sales made by a particular shopping mall for the past 5 years. So you can use that historical data to now make predictions of possible sales that shopping mall can still have in the nearest future. For example, you can also, in predictive modeling, you can predict likelihood of a disease breaking out, such as diabetes. Now, if I can have access to the age of an individual, the gender of an individual, the weight, the average glucose level, the daily calories of an individual, it is possible for me to predict if that individual can eventually have diabetes or not. And also, you can still use time series analysis to forecast a company sales. Forecast is all about predicting what could be the sales, what could be the future sales of a particular company. Forecasting is all about predicting what could be the future sales of a particular company. So we can use time series analysis for that. So in predictive programming, you need to collect historical data, you analyze your historical data, and you train your model. Now, in training your model, you are trying to let your model understand your data. You are trying to teach your model how to identify different trends and patterns in your data. So it is those trends and patterns that your model will now use for prediction when it's working on a new set of data. So now you can build several predictive models using different algorithms. There are different machine learning algorithms you can use for predictive analysis. we have support vector machine, we have regression algorithms, we have neural networks, we have decision tree algorithms, we have k-means clustering, we have naive Bayes, we have several machine learning algorithms that we can use for predictive analysis. Now, all these machine learning algorithms have different ways of making their own predictions. They have different parameters you need to put into consideration whenever you want to use them for your predictive analysis. So we have several applications of predictive modeling. Most industries use predictive programming either to detect the cause of the problem or to improve future results. So application of predictive modeling is not limited to fraud detection. You can use it to you can use it to detect fraud. You can use it in sales forecasting to forecast future sales that a particular organization or company can have. Yeah, you can use it to forecast weather. You can use it to what? To enhance business performance, in speech recognition, in news categorization, in vehicle maintenance. These are the different predictive modeling applications that we have. So now, for us to build our predictive models, there are some steps we need to take. And the first step is you need to, you start from your data set. It is the features of your data set that will determine the kind of outcome you can predict. So the first thing you need to know is to explore and understand your data set. You need to what? Explore and understand your data set. And in understanding your data set, you need to understand the different features of your data set. And the features of our data set are the different columns of our data set. And every column will always have a colon header. So you need to understand the different columns of our data set. So after that, every data set you want to use for predictive analysis, you always have two major components. They always have two major components. The first is what? The features. The features are called the inputs, the predictors. Those are the column headers that you need for predictions. Like when I was giving an example of if you want to predict diabetes, if you want to predict occurrence of diabetes in a particular patient, there are some features you need. You need the weight, the age, the gender, the height, etc. Those are what we call the predictors. So in our data sets that we want to use for predictive analysis, our data sets will always have two components. The first is what? The predictors. Those predictors are also called the features. They are the inputs or attributes that will be used for predictions. So these predictors are simply what? Variables of our data sets that will be used for predictions. They can be more than one, and hence, since they can be more than one, they can be represented by what? A feature matrix. So now, X is a common notation used to represent a predictor. It's not important to use X, but it's a common notation that is being used to represent our predictors. So a list of all the feature names is called the feature name. A list of all the features that we want to use for prediction is called the feature names. So now the second component of our data set will now be the output. That is the response. That is the particular column we want to predict. So this is the output variable depending on the feature variables. That is, the response component is the feature you want to predict. And our predictions will always be dependent on what the input parameters we use. So the output variable depends on the feature variable. So this is commonly a single response column. and it is represented by a response vector, and y is a common notation used to represent the response vector. So the data set we want to use for prediction, we always have two components: the features and the response. The features are what? The input variables you want to use for your predictions. And now the input variables can be more than one. The more the input variable, the higher could be the accuracy of our output, of our prediction. So the second component is now the what? The response. That is the what? The single colon you want to predict. So I believe we understand this. The data set we want to use for prediction. You know, our data sets will always be, our data sets are always a combination of different rows and columns. So the columns are what? Different attributes in our data sets. So the data sets we want to use for prediction we always have two components. The first component will be what? The input component you want to use for prediction. And the second component will be what? The response you want to predict. So now, when you have a data set you want to predict, you now be the one to identify the columns you want to use for prediction and the column you want to predict. So now, how will our model now understand our data set? That is what we call training. You know, we have different machine learning algorithms. We have different machine learning algorithms we can use for prediction. So the process of teaching a machine learning algorithm about the different features of our data set is called the training aspect. So we'll be the one to train our machine learning algorithm to identify different components of our data set, to uncover different features in our data set. And when our machine learning algorithm has understood the different features of our data set, it can now use those features to make predictions. So I hope you understand. When you have a data set you want to use for prediction, the data set will be in two components. The first component will be what? The input variables you want to use for prediction, and the second component, which is always majorly one column, will be what? The output of your prediction. So it is now your responsibility to now train your machine learning algorithm about the features of your data set. Exactly. But input can be more. So now, before we train our model, the second thing we need to also do on our data set is to what? Pre-process our data sets. That's the second thing we need to do. You know, the first thing we need to do is to what? Understand your data set and understand the input variables you want to use for prediction and the output variable you want to predict. So after that, the second thing you need to do is to what? Pre-process data sets. Now, the data cleaning activity we are well aware of is one of the pre-processing steps. Now, pre-processing is all about making a data set suitable for prediction, making a data set usable by the machine learning algorithm you want to use for our prediction. So now there are different processing steps we can employ. There are different pre-processing steps we can employ. Sorry. So there are different pre-processing steps we can use for our prediction. We can carry out during pre-processing our data sets: standardization, normalization, binarization, if the prediction you want to carry out has just two values, that is, the output of a prediction should either be yes or no. Let's assume that you want to predict flood. You want to predict the possibility of having flood in a particular year. The possibility could either be what? Yes or no. So binarization involves ensuring that your output variable will either be yes or no. We also have encoding categorical features in our data set. Now, depending on the machine learning algorithms you want to use, in your data set, you can have different values. In our data set, you can have different values. It's still possible for you to, depending on the machine learning algorithm you want to use, there may be a need for you to encode the values in your column using either zeros or ones. Now, another preprocessing technique is imputing missing values. If there are missing values in your data set, you may want to replace those missing values with what? Zero, instead of having an empty input. So these are the different preprocessing steps we can carry out. Now, different algorithms have different preprocessing steps they need. Now, the beauty of it is that the beauty of the preprocessing aspect is now that Python has different packages for this preprocessing activity. So what you only need to do is what? Just call the preprocessing module you need for a particular machine learning algorithm you are using. So this processing steps are not necessary for every algorithm. Exactly. Different algorithms have different preprocessing steps. An algorithm may have more than one. Exactly. So now, after you've preprocessed the algorithm, after you've preprocessed your data set, the next thing you need to do is to now choose a particular machine learning algorithm you want to use for your prediction. So the next thing will now be to choose a particular machine learning algorithm you want to use for your prediction. So now we have different machine learning algorithms that are suitable for different predictive activities. So that means before you choose a particular machine learning algorithm, you need to know if that particular machine learning algorithm is appropriate for your predictive for your prediction. So now I want to give us a brief information about different machine learning algorithms we have. Number one, we have linear regression. It's used for what? Predicting a continuous dependent variable based on one or more independent variable. We also have logistic regression. It is used for what? It is perfect for what? Binary classification task. That is, if your outcome will have only two values, which could either be what? True or false. Now you can use logistic regression for that. We also have decision tree algorithm. It is a tree-like model that is used to make predictions based on decision rules derived from what? The features in our data set. We also have random forest. It uses what? An ensemble method that builds multiple decision trees and merges the outcome together. Now, random forest is an example of, it also uses what? Decision trees. It uses what? Multiple decision trees. And at the end of the day, it will now merge the output together as one. So now, in most instances, we always have a higher accuracy when we use random forest algorithm for prediction than when we use decision tree. We also have support vector machine. It's also a binary classifier. If the prediction you want to make, if the output or outcome will always be true or false, you can also use support vector machine. We also have k-nearest neighbor. We have naive Bayes. We have gradient boosting machines. We have time series analysis. When we want to carry out forecasting, that is, forecasting is a type of prediction. Now, in forecasting, you want to predict future outcome of a particular feature. That is, it could be perhaps you want to predict future sales of a particular company. Then you can use this time series analysis. We also have artificial neural network. We have convolutional neural network. We have recurrent neural network. We have long short-term memory algorithms. So these are the different machine learning algorithms you can use for your predictive activity. So after you've acquired your data set, you've preprocessed your data set, the next thing will now be to identify the best machine learning algorithm for your prediction. Okay. As in, this slide should have come before the previous, before identifying. So now, during our preprocessing activity, it involves different activities. You know, preprocessing is all about making a data set suitable for the tasks you want to do. So it involves data cleaning that we are already aware of. And data cleaning involves what? Handling missing values, removing duplicates, correcting errors in a data set. Preprocessing also involves what? Transforming a data set. That is, converting a data set into a suitable format for prediction. And now different data transformation steps can be carried out. Normalization, that is, if some values are not in numeric format, you may need to convert them into numeric format. Now, encoding categorical variables. Now, there are different methods of encoding categorical variable. You can use one-hot encoding, you can use label encoding, you can use binary encoding. In binary encoding, you can only use either zeros or ones. You can use different values between zeros and ones. We also have feature engineering. This will involve creating new features from existing features in order to enhance predictive task. Okay, we also have data reduction. Now, if you have a large data set, it's possible that you don't need all the features for prediction. So data reduction involves reducing the size of your data set by selecting the columns you need for your prediction. So feature selection, it involves identifying the most important features you need for your. We also have dimensionality reduction. It involves reducing the number of features while retaining the most important features that is needed for our prediction. So now, another important step in building a predictive model is to now divide our data sets into two. That is the training set and the testing set. After you've identified the machine learning algorithm you want to use for prediction, you need to You need to train that machine learning algorithm. And training involves teaching your machine learning algorithm about the different features of your data set. So now if you are using a single data set for your for building your predictive model, you need to divide the data sets into training sets and testing sets. You need to divide it into training sets and testing sets. Mostly, our training set is always higher than our testing set. So it could be 80%. We can use 80% of our data set for training, and we use the remaining 20% for testing. And we can also use what? 70% of our data set for training, and we use the remaining 30% for testing. So training involves what? Teaching a machine learning algorithm about the different features in her data set. You want your data set, you want your machine learning algorithm to understand the different patterns and features in her data set, so that when her machine learning algorithm has understood her data set, it can now what? It can now make predictions based on what the machine learning has understood. It's just like from experience. You know, as we grow up, if it will rain in a particular day, from experience, you can predict. If you wake up in the morning and you look up into the sky and you see how cloudy the sky is, location of the cloud, and based on past experiences, you have been told that throughout this week, as in we've been having serious rains. So let's not say today you also, as you wake up this morning, you went outside, you see discover that the sky is cloudy. You can predict that what? It could rain. Now, your prediction can be true and it will not be true. Your prediction can be what? It can be true and it will not be true. That's the reason why when you've used your machine learning algorithm for prediction, you still need to evaluate the performance of your machine learning algorithm so that you know how accurate it is. So you can now use those performance metrics to now conclude that, okay, for this particular kind of scenario, this particular machine learning algorithm will always yield a high accuracy. So the training set is what? A subset of our data that we want to use to train our model. The training set is what? A subset of our data that we want to use to train our model. You know, we have different machine learning algorithms and they can be used for different tasks. So how will one machine learning algorithm be able to solve different tasks? You need to train them. You know, if you want your child to become a footballer, there's a way you train them. If you want your son, your first son, to end up and become a pastor, there's a way you train them. If you want your son to end up to become a musician, there's a way you train them. So any activity you want to use your machine learning algorithm to do, you'll be the one to what? To train those machine learning algorithms. So our training set is used to what? To let our machine learning algorithm understand different features and patterns in our data sets. So your model what? It will learn different patterns, different relationships, and different features in our data sets, so that at the end of the day, your machine learning algorithm will be fit for the prediction you want to carry out. And why will they be fit? You have trained them on how to carry out prediction based on the historical data you've used to train them. So now the second set of our data sets will now be what? The testing set. After you've used a portion of your data set to train your machine learning algorithm, you can now use another portion of your data set to what? To test a machine learning algorithm. That is, you want to know if your machine learning algorithm has understood the different patterns and features in a training set, and our machine learning algorithm is now fit to make prediction. So during testing, you want to know how accurate or how well a machine learning algorithm has learned from a training set, and how accurate a machine learning algorithm will be able to what? To make or carry out prediction. So I hope you understand the difference between the training set and the testing set. So now the Python module we'll be using has different packages for different steps of this model development. It will be done automatically by the Python module we are using. So you won't be the one to manually select the portion of your data set you want to use for training or the portion of your data set you want to use for testing. Now, to go back to the, let's say, topics like statistics, like algebra, and all those things before you can get. Now, if you have the basic understanding of that, it will help you to understand the task at hand. You know, if you have those basic understanding, it will help you to understand the task at hand. Now, you discover that my manner of teaching, I'm trying to be slow because of a different background. Maybe I'm talking to computer science students, the approach will be different because I know that I have understanding of all these algorithms. But I'm aware that we are coming from different background. So that's why I'm taking it this way. So if you are if you have the basic understanding of statistics, you will know that, okay, for me to understand my data better, let me carry out correlation analysis between my variables so that I will know the kind of prediction I want to do. Let me carry out covariance tests. Let me carry out t-tests, all those tests. So I just want us to have an understanding of the different steps before I do the practical application. Now, the reason why Python is the best for this is that it has different packages that you can use for all these tests, all these stages. You can see this code snippet I use. Now, the package we use for the training and the testing, it's what, as in we'll fetch, this is the module we use, model selection. So from scikit-learn, you import what? The train test split module. So it is that module that will automatically divide the data set into training test and also the testing test. And you also carry out the training of the algorithm for us. We'll understand when we begin the practical aspect. Okay, now you can still have an optional subset of our data that you can still use to validate your data set. Because during our training activity, it is possible that your machine learning algorithm would have memorized the different features and patterns in your data set. It would have memorized the different patterns and features of our data set to the extent that if you now introduce a new data set, it will perform woefully on the new data set. But on the previous data set that you've used for training, it will be giving you a higher accuracy. If you now introduce the new data set, it will give you a lower accuracy. That is what we call overfitting. Instances whereby instead of your machine learning algorithm trying to generalize on your data, it has now memorized the different features of your data set to the extent that it can only give you a higher accuracy when it's working with the data set you've used for training, and it will not give you a lower accuracy when when it's working on a data set, when it's working on a new data set, apart from the data set you've used for training. A perfect machine learning algorithm, after you've trained it, it should be able to make prediction on any similar data set, besides from the data set that has been used to train that particular machine learning algorithm. So in that case, you can use what? You can introduce a validation data set to tune the different parameters of your machine learning algorithm so as to avoid what we call overfitting, and it will be suitable to make predictions on new data sets. Okay, another preprocessing step we can take when preprocessing a data set is to what? Is to handle imbalanced data. That is, when a feature in a data set is more than another feature, we can what? That is called imbalanced data. So there are different techniques we can use. We can use resampling techniques. An example of a resampling technique we can use is what? Is smooth. That is what? Synthetic minority oversampling technique. Okay, preprocessing a data set will also involve what? Identifying different outliers in her data set. There could be a particular value in a data set that is not consistent with other values in a data set. For instance, if it's a salary data set, you will now discover that a particular gatesman has a salary that is higher than the salary of the general manager. You know that is not possible. That is what an outlier. So preprocessing a data set also involves what? Identifying and removing all outliers in a data sets. Okay, if you have a small data set, you can still generate additional data sets so that your data set will be robust, because the more you're training data sets, the more accurate your prediction will be. The better your machine learning algorithm will learn the features. If you have a large data set, it will be easier for your machine learning algorithm to learn well with a large data set compared to when you have a small data set. So there could be a need for you to generate additional data sets so that your machine learning algorithm will be able to learn well. And another preprocessing activity we can carry out is what we call data integration. If you have data sets from different sources, you can find a way to merge them together so that you can use them for your machine learning predictive model development. So these are the different processing activities we can carry out. So we've talked about the need for us to train. The reason why we need to train our machine learning algorithm is for our machine learning algorithm to identify the different features, the different patterns and trends in a data set, so that it can use those features to make future prediction. Now, Python has different packages we can use for our predictive activities. It has different packages. Packages like what? Scikit-learn, TensorFlow, and PyTorch. So today we'll only be focusing on how to use scikit-learn for our predictive modeling. So scikit-learn is one of the most widely used Python library for machine learning activity. It provides simple and efficient tools for data mining, data analysis, and machine learning. Now it is built on other existing libraries such as NumPy, Pandas, and Matplotlib. I told us during the last class that you can use different packages together. For instance, you know that if your data set is in form of is in a tabular format. If you want to import that data set, you need what? You need pandas. If your data set is in an array format, you use what? You need a numpy package. Now, if you want to carry out visualization, we have different visualization packages you can also use with your data set. So scikit-learn also works with all those packages. So scikit-learn has a wide range of algorithms that have been inbuilt into its environment. So you don't need to write all the codes on your own. What you only need to do is to call a particular machine learning algorithm you want to use for a particular task. So scikit-learn has different machine learning algorithms you can use for classification, regression, clustering, dimensionality reduction. For instance, it has different linear models like linear regression, logistic regression, support vector machines, decision trees, random forest, k-nearest neighbor, k-means clustering, principal component analysis. So all the machine learning algorithms you need, scikit-learn package already has them. So you only need to call a particular machine learning algorithm you want to use for your machine learning task. Now, scikit-learn is also easy to use. Now, those algorithms have similar steps for prediction. You preprocess them. You make sure that the machine learning algorithm is fit to carry out your prediction. It has different packages. So those machine learning algorithms, they have almost the same steps. And scikit-learn also have different modules for different predictive modeling steps. So if you want to predict, it has a function you can use for prediction. If you want to generate performance evaluation scores, it has a function you have to call. So it also has different inbuilt preprocessing module you can also use. It also has different performance evaluation metrics you can also call. It also has different modules like the train test split. So you don't need to manually carry out any tasks. You only need to call a particular module you need for a particular model development step. And also, scikit-learn can be integrated with other libraries. It can work with other libraries. And also, scikit-learn has a rich documentation. So scikit-learn also has a learning community. So perhaps you are carrying out a task and you don't know what next to do. It has a global learning community that you can join. You throw in your problem and they provide them different suggestions. And it also has a rich documentation, a user guide or tutorial with different examples. So you can find the user guide on how to use scikit-learn on this environment. So if you know you want to go into predictive analysis, and you know scikit-learn is one of the Python packages you need to know, you can go to this link to get a full documentation on how you can use them. So now, when you want to carry out your prediction using scikit-learn, I want to walk us through the different stages. Number one, you need to load your data. That's the first step you need to take. You need to load your data. And you already know the Python libraries you use to load your data. That is Panda or NumPy, depending on the type of data you are working with. So if you want to load your data, what are the packages you need to load? You import what? Your pandas. You import what? You import your pandas. That's the major Python library you use to load your data sets. Also, during your model development, you also need to what? To divide your data set into the training set and the testing set. There is a module in scikit-learn you have to call. That is what? scikit-learn.model selection. From scikit-learn.model selection, you import what? The train, test, split module. I believe you understand what the train, test, split module we do from what we've said so far. We use that module to what? To divide our data set into what? Training data set and the testing data set. And also use it to what? To train our model. I hope you understand. Okay, the second thing after you've loaded your data is what? Is to split your data into training and testing sets. So what's the model, the scikit-learn module you need? Train, test, split. And where will you fetch that module from? From scikit-learn.model selection. Now, when you want to, this is the syntax you need to use to divide your data set into training and testing sets. Now, remember I said our data set we have two components. The training component, as in it will have two components. The feature component, which are the inputs that will be used for our prediction, and the colon, that will contain the value to be predicted. And I said the input values that will be used for prediction are always labeled by what? X. So that input value, we also have a training set and a testing set. And also our response value, we also have, that is denoted by Y, we also have a training test and also a testing set. And I believe you already know what you want to use your training set for and what you want to use your testing set for. I believe you understand. So now, this is the syntax. X string, the subset of data set, the subset of your input data set that you want to use for your training. That is called what? The X string. You understand X string? I said that a data set, it has two components. The input columns you want to use for prediction, and what? The output column. The input column are always denoted by X, and the output column are always denoted by what? The Y. Now, there's a need for you to train your model so that your model will understand the different features in your data set. So now, the input values, you create a subset that will be used to train a model. You still create another subset that will be used to what? To test a model. Now, for the response component too, you create a subset that will be used to what? To train a model, and still create another subset that will be used to what? To test a model. So the training, the testing, and the splitting will be done by a module called what? Train, test, split. And it is found in the what? In a scikit package. So now, this is now the syntax that will be used to carry out the training and testing. X string. Sure. So now, I just want you to understand those lines of code. So that when you see them, you'll be able to relate. Extreme. These are what? A subset of my data set, of my input data set that we use to train my model. X-test. A subset of the input data set that we use to test my model. Y-chain. A subset of my output column that will be used to train my data set. Y-test. A subset of my output column that will be used to test my model. Why do we need to test our model? So as to know if our model has understood the different features and patterns in our data set. So now, this is now the model, the scikit model that we've imported, that we use to what? Train. You train, you test, and it would have what? Splitted your data set. Now, I would have preferred it to be split, train, test. But it is always what? Train, test, split. So now, this is what? This S contains what? Our input columns. Our input values that we use for prediction. Y, the output column. Now, test size. Is it 80-20? If it's 80-20, you use 0.2. If you want to use 70% of the data set for training and 30% of the data set for testing, it will be what? 0.3. So random state is always equals to 42. So I just want us to understand these lines of code so that when you see it, you will understand what it's doing. Okay. Okay, now, after we split it, we now need to what? Preprocess. You know, I told us different algorithms have different preprocessing steps. Now, there are what? All those preprocessing steps are what? Modules are already input into our scikit-learn. So what we need to do is what? We want to carry out preprocessing. This is the package for preprocessing. scikit-learn dot preprocessing. What's the preprocessing step you want to carry out? Standard killer. I want to use standard killer for my preprocessing activity. So I will use standard killer. So now, that is, I want my scalar, my preprocessing method. I want to use my preprocessing method to preprocess my data set. I'll use this syntax. Now, this is what? S-string. I believe you already the subset of our data. Now, X-test. The subset of our data set that we want to use to test. So this is the what? Preprocessing method I want to use to what? To preprocess my input data set. So now, after I've splitted my data set.
If any data is unfit, it will not go. Because we say scalar should be fit.
Which one?
I mean, at this point, if any data is fit, this thing does not accept it.
If any letter is not what?
Fit. It's unfit.
Now, the essence of this means that my preprocessing method should make the data set I want to use to train my model to understand the task, to be fit for the training tasks I want to carry out. That's the essence of the fit. No, it's not a must. If you want to divide your data sets in 80-20 proportion, then it will be 0.2. 0.2 means 80% of our data set will be used for training, 20% will be used for testing. If you want it to be 70, ratio 70-30, it should be 0.3. 70% will be used for training, 30% will be used for testing. It's only the input. It's only is output. Is the input value you want to use for prediction. The what? Yeah, that's a default value for the random sample. Now, the random sampling, it will be an inbuilt model that will automatically choose different values in a data set for the training activity. It's not as if it will be the splitting will not be in a sequential order, but it will be chosen randomly. As in, when I'm doing the demonstration, I will display the content of the S3 and the S test for you. So you see that it will be different rows in a column that will be used for training. It will be in a sequential order. It will be in a random order. For instance, it can choose row 1, row 5, row 8, row 20, row 23 as the training set, and it still choose row 3, row 5, row 7. So the rows will be selected in a random format. It will be in a sequential format. So now, model training. Under the model training, you need to select the particular machine learning algorithm you want to use. Now, if you want to import a linear model, like logistic regression or linear regression, you use what? You import them from this scikit-learn package. If you want to import any preprocessing module, it will be from what? scikit-learn.preprocessing package. If you want to import your machine learning algorithm, it will be from scikit-learn dot the respective classification or category of that particular machine learning algorithm. For instance, take a look at this. If you want to use logistic regression or linear regression, they are linear models. It will be found in what? scikit-learn.linear model.
So I'm going to do this without
Yeah. I just want you to understand this.
So let me take an assumption like this one now. The model for this thing will be like the X, Y. That's the number. So maybe like an assumption, maybe you have like X, Y1, Y2, Y3 as multiple progression.
It's not done like that. Don't let us assume. Just understand this background knowledge first. So now, from this linear model, the model I want to use for my prediction is what? Logistic regression. I will import logistic regression from here. So this is a function that contains different steps of using logistic regression algorithm to train a particular model. You know, what's an algorithm? Different steps you need to take to solve a particular problem. Now, there's a way, if you want to use logistic, it's just like you want to solve a mathematical problem. Let's say you want to find the root of a quadratic equation. You want to carry out the root of a quadratic equation. There's different steps you need to take. So when you want to write the code, you write it sequentially. That okay, find the variable, the value of A, B, C. Use this from almighty formula, slot it in. So all those steps have been inbuilt into different modules of my program. So the steps needed to use logistic regression to train a model has been inbuilt into this model. So you don't need to write the lines of code on your own. What you only need to do is to call the function that will carry out the task for you. So this is now my what logistic regression. So now, if I now want to train my model, I will use the what? I will train it on what? You can see this S-train scale. That is the preprocessed subset of my training set. You know, X is the what? Input variable. This is what? The preprocessed input variable that I want to use to train my data. And this is what? The output variable. So for logistic regression, it is the what? The input variable that I want to use to train a model that will be preprocessed. So different algorithms have different preprocessing steps and different learning steps. I hope you understand. Don't worry, the example I will give, I will use at least 5 different machine learning algorithms on the same task. So you now understand the different steps. Yes. So now, after you've trained your data set, after you've trained your model, you now believe that your model has what? Has understand, your model is fit to make prediction on similar data because it has understood the different patterns and trends in the same data. You can now go ahead to use them for your prediction. So now, when you want to predict, this will be the distance. Now, you know my model, the model I'm using is what? Logistic regression. It's not the function will now be my model dot predict. You're welcome. What will I use for the prediction? My preprocessed input subset. I believe you understand how we got it. Our data sets, we divided them into what? The X and the Y value, the input value and the response value. Now we've scaled our input value to make it fit for a model prediction. So it is now the input value that we use for prediction. So this is the syntax. Model.predict. What will be used for prediction? The subset that will be used to test. You can see that we use the X string for training, X text for prediction. So you use your X string to train your model. You now use your X test to test your trained model. So now, after you've trained your model, the next thing you need to now do is to what? Is to evaluate the performance of your model. Is what? Is to evaluate the performance of your model. You now want to check how accurate my model is. That's what evaluation entails. The predictions I've made using logistic regression, how accurate it is, how reliable it is. There are different metrics we can use to determine that. So now we can use accuracy, we can use root mean square error, we can use different metrics. We can use precision, we can use F1 score, we can use sensitivity, we can use different metrics to evaluate our model. So now, I want to In programming, there's what we always call cheat sheet. It will give you, it's just a document that will give you different lines of code you can use for different activities. Let me. It still depends on the algorithm you want to use, also depends on the data set you are working with. It always depends on the data set you are working with. But during preprocessing, you can now make your data set suitable for your particular metrics. It depends on the task you are carrying out. You can use them at the same time. I will show us the syntax. Now, let's take a look at this. And this. Now, let's take a look at this. If I want to employ standardization for my preprocessing activity, these are the lines of code you can use. If I want to explore normalization for my preprocessing activity, these are the lines of code I can use. Now, all the different preprocessing types, I can always import them from what this scikit-learn module, preprocessing. Scikit-learn has different preprocessing modules that you can use for preprocessing tasks. So now I want to use standard scalar. I will import it from what scikit-learn.preprocessing. I want to use normalizer. I will import it from what scikit-learn.preprocessing. What's the syntax? This is the syntax. And you see, you use what? String length, string, string, extents. You just follow this syntax. I will keep on to. I will send the document to you. I just want to. So any preprocessing module, any preprocessing task you want to use, it's already inbuilt into scikit-learn. What you only need to do is to call them. What you only need to do is to call them. Now, I only want us to have the basic understanding. And so I see you have to write the code often. But at least when you have the code, you should understand the different steps, the different syntax in the code. That's what I'm trying to achieve with this. So now, if you want to use a binarizer as a preprocessor, this is the syntax. So every preprocessing task you want to do, every preprocessing module you want to use will be fetched from what scikit-learn.preprocessing package of scikit-learn. So now I want to create my model. If I want to use linear regression, this is the syntax. If I want to use support vector machine, this is the syntax. You can see that the example I gave before was logistic regression. It's still a type of what? It's still a linear model. So every linear model will be imported from what? scikit-learn.linear model. So if you want to use linear regression, import it from what? scikit-learn.linear model. If you want to use logistic regression, you import it from what? scikit-learn.linear model. If you want to use SVM, you import it from what? scikit-learn.svm. You want to use naive Bayes, you import it from what? scikit-learn.naive Bayes. If you want to use KNN, you import it from what? That's from SVM. So these are the syntax of how to import different machine learning algorithm for different tasks. So now, okay. After you've made your prediction, you want to evaluate the performance of your model. These are the different metrics you can use to evaluate the performance of your model. I want to carry out the accuracy. I will use this from scikit-learn.metrics. Scikit-learn.metrics contains different performance evaluation metrics that you want to use to evaluate the performance of your model. So what you only need to do is to import those modules from our scikit-learn package. And this is the syntax. Scikit-learn.metrics import the accuracy score. How are you going to use the accuracy score? Accuracy score. Y-test. And what is Y-test? The subset of my output variable that was used to test my model. And what is Y_prep? The predicted output. So you now want to carry out how accurate is the predicted output compared to what? To the output subset used to test my model. So now, if I want to generate confusion matrix, this is the syntax. Okay. So scikit-learn has different inbuilt modules that we can use to carry out, that we can use to evaluate the performance of our model. So these are the different syntax. So the tasks you are doing will determine the kind of performance evaluation metrics you will go for. So if you are doing clustering and you want to compute the adjusted rand index, you import it from what? metrics. You import what? Adjusted rand score, and this is how you compute it. You use Y-true. Y-true is the same thing as Y-test against what? The predicted value. So you can go through this. I will upload it for us.
What is supervised learning and unsupervised?
Yeah. Yes. We have different machine learning algorithms. In fact, we can generally divide machine learning algorithms into supervised and unsupervised learning. Now, the classification is based on how they carry out their machine learning task. Now, in supervised learning, my machine learning algorithm will be working on data sets that has been labeled. But in unsupervised, my machine learning algorithm will be working on their machine learning algorithm that can still carry out prediction, even if you've not labeled your data. Exactly. So those are generally the two major categories of machine learning algorithms we have. So now let's now see. Okay. I want to use this data set for illustration. So we'll be working with this data set. The data set on flood prediction. It's the rainfall data in Abuja from year 1901 to 2018. So now it contains what? It keeps record of different volumes of data. Different volumes of rainfall every month. Now, in January, we have this volume of data. It will not be a real data. I just saw it online. It will not be a real data. So we have, in February, we have this volume of data. In March, we have this volume of data. Now, the annual volume of rainfall in that year is what? 3,248, as in, what's the size? Now, was there a flood in that particular year? Yes. So this is what we call our historical data. So you can now see from 1901 to 2018. So now this is my data set. So I now said in my data set, when I have my data set, I need to understand the different variables in my data set. So I understood that, okay, colon A, that's the name, the city. Colon B, that is the year. From colon C to N, those are the words. It keeps record of the volume of rainfall from January till December. Don't look at it, don't look at it. Don't open it yet. Colon O contains what? The sum of all the rainfall from January to what? Till December. That's the what? The annual rainfall. Now colon P. That's the column that keeps record of what? Flood situation in that particular year. So this is my data set. Now remember what I said? I said we what? Divide our data set into what? Our data set will always have two components: the input columns and the output columns. The input columns are the columns that can be used for prediction. Now the output column, that is the column I want to predict. So now take a look at this. So now my input column, the column that could be used for prediction, what are the columns I will need for prediction? Do I really need column A for prediction? No. Do I need column B for prediction? Yes. Because, if we study it, there will always be an instances whereby the rain situation in a particular year will be very similar to a previous year. So I need this year column. I also need what? All these column. I may not really need the annual column as an annual rainfall column, because it's still the summation of the rainfall between January and December. So now, what will now be my output column? My response column? What? Column P. That is what? The flood. So I now said my input column will be represented by what? X. The predicted column will be represented by what? Y. Now, normalization, as in, so those are the different, I've identified the different components of my data set. So now I also said we still need to we'll need to split our data set into training set and test sets. So now, if this column should be my X column, my input column, it will be automatically splitted into training sets and testing sets. I hope it will be automatically splitted into what? Training sets and testing sets. So the training subset of this will be what? X_train. The testing subset will be what? X_test. Okay, now this is my column Y. My column Y will also be splitted into training and testing sets. The training set will be what? Y_column. The testing set will be what? Y_what? Test. Okay. I will need another column. This column. If I now want to make my prediction, this will contain what? My predicted values. I want to predict if there will be flood. I want to what? Use this data set to predict if there will be flood. Now, this column, this will keep record of what? The prediction, the output of the prediction, if there will be flood or not. So I hope you understand that step. Oh, that's all the story we've been saying since morning. So now, what else do we still need to do? We need to pre-process our data set. That is, we need to make it fit for the prediction we want to carry out. Now, we have different numeric values. 28.7, 44.7, 51.6, 160, 174. We'll be using the algorithms we'll be using. Now, the preprocessing step we want to use is now scaling. We want to standardize our data set. We'll be using what we call a scalar. Now, that standardization will convert all these numeric values into between 0 and 1. 0, 0.1, so that they will be uniform. 0.2, 0.3, 0.4. How do you want to do it? I'll just call the preprocessing module to carry out the scaling for me. So now it represents all this value with different scaled equivalents. So 28.7 could be, at the end of the day, could be 0.7. 44.7 could be 0.9. It will convert all the numeric values to values between zeros and 1. Now, take a look at this value too. I still need to convert this to what? 1 or 0. 1 could be for yes, 0 could be for 1. 0 could be for no. Those are what the preprocessing steps I need to take. Now, another preprocessing steps I need to take is what? To clean my data. I already know what data cleaning involves. You identify missing values, you replace empty values, you remove duplicate rows, etc. Those are, well, this data. So this is the data set I want to use. So now in this example, I will be using I will now be demonstrating how to use different machine learning algorithms: KNN, logistic regression, SVM, decision tree, and random forest. I can use those 5 machine learning algorithms for my prediction task. What will be the first step? I need to do import my data. That will be the first step. So now if I want to import my data, what do I need to do? Thank you. Yes, as in people online would have been. Thank you. Okay. So now, the first thing I need to do is to ensure that I import my data set into my Google Colab environment. Okay. Okay. Let me do that. Ah, okay. So now I need to upload my data set. I believe you already know how to do that. Upload Abuja Flux. I've uploaded it on the general Telegram group. So now I've uploaded it on my data set. So what we need to do is to what? To copy the part. Copy part. So now the most important library I need here is even pandas. I don't even need this for now. But what do I need pandas for? To read the content of my data set. So I've read it. So the normal data exploration activity we need to do is to what? Examine the first 5 columns. Now take a look at this. My data set was loaded into this identifier data.head. I've seen the difference, the first 5. I've seen the first 5 rows in my data set. Okay, I can see examine the last 5. Data.tail. You can see I've been seeing the last 5. Okay, I'll be making reference to the columns. I'll be making reference to the columns of my data set. So that's the reason why there is no way you want to. If you want to check the columns of your data set, you use data.columns. So now my data set contains what? City, year, January to December, annual rainfall, floods. Now, I don't need the city column. I can manually drop it when I was checking the data set. But perhaps I don't want to alter the data set. So that is why I kept it. But from my code, I can still remove that column. To remove a column, we use this syntax, the drop module. Data does drop. What's the column I want to drop? This is the column I want to drop. Column city. Axis equals to 1. That is, it should work on the data set uploaded. So now I've done this. So now if I now check my data columns, you see that city is no more, has been dropped. Now I want to check if there are missing values. To check missing values, you can use the isNull function. If you check the missing values, you can see since all are zeros, that means there are no missing values in all my columns. Okay, now, like I said earlier, I need to convert the string value in colon floor to 1 and 0. I want to represent yes with 1 and no with 0. This is the data set. This is the column. Remember the quiz we did? How to replace a value. Replace function, blah, 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 let's go. So this is the module, the function we use. So replace yes with 1, no with 0. So now I've done that. Let me now examine my data set again. You see it as what? Because my algorithms can only predict in ones and zeros. So now my floor column has been changed to what? 1 is yes, 0 is what? No. Now I need to split my data into what? The columns that we use for prediction and the columns to be predicted. Those are the X and Y column. If I want to split my data, I'll use this ilog function to do that. So this means that what? Column 1 to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So these are the columns I want to use for prediction. Those are my what? X column. The column I want to use the column to be predicted is what? My Y column. And my Y column is what? Flood. I hope you understand. So now, what do I want to use this line of code for? I want to check my input subset, X, the content of X, the subset that will be used for prediction. I want to check the subset, the content. I believe you understand this. Split this into column 1 to 14 and save it inside X. So now if I run this, so I will have this. Now I want to separate the column to be predicted. That is the flood column. -1, that is the last column. So if I print that, so this is so Y is the column to be predicted. So I've successfully split my data set into what? X and Y. Now what will be the next thing? Split my data set into training, testing, select the machine learning algorithm I want to use, train the machine learning algorithm, use the machine learning algorithm to predict. After prediction, evaluate the performance of the machine learning algorithm I've used for prediction. So now the module we'll be using, the Python module we'll be using is what? Scikit-learn. It has this preprocessing, you can see. The SLM preprocessing module includes what? It has different preprocessing steps or preprocessing function we can need: scaling, centering, normalization, binarization. So I will import from my scikit-learn, I will import the preprocessing module. I want to scale my values between 0 and 1. So now I'm using this word, min mass scaler. If you check this, okay, scikit-learn, let me check this. you can see, if I want to use standard scalar, I can just copy this syntax and use it to preprocess to scale my data set. But here I've used what? Min max scalar. So now, if I want to view it, this is the what? This is the difference. Now this is where I need NumPy. It has now converted all my values into array of values between zeros and 1. So now the first column, this is the equivalent value. The second column, this is the equivalent value. It has been scaled to this value. Now the next step, I want to divide my data set into training and testing data sets. What I need to do is to what? Is to import the module that will be used to do that. From scikit-learn.model selection, import what? Train, test, speed. This is the model. This is the module that will be used to split my data set into training and testing. So now, like I told us, this is the syntax. At the end of the day, you discover that my data set will be split into 4. Yes, originally it will be split into X and Y, but X will also be split into X string, X test. Y will also be split into what? S test, Y test, Y string. So now I need to determine which subset of my data set will be X string, which subset will be S test, which subset will be Y string, which subset will be Y test. So this is the scikit-learn module I will use for that. So now, what will be the input to that module? My what? X subset. My what? Y subset. Now, what is the proportion of my training data set and testing data set? 0.2. And 0.2 means 80% training, 20% as my test data set. I hope you understand this. You don't need to cram. I just want to so that when you see the code, you know what was done. So that if there is an error, you should be able to read the error and understand what is wrong. That's the essence of this. Okay, now I want to use this to check the dimension of my S string. I believe I can be using S string. Okay. You can see it's generated an error. You can see what's the error? S string is not defined because I've not carried out the division. I jumped this. So now, once I've done this, it would have what automatically splitted my data set into X string, X test, Y string, Y test. So now, I can now check the respective values inside X string, X test, Y string, Y test. So now let me check the. So my X string, the subset of data set I want to use to train has what? 94 rows, 13 column. X test, it has what? 24 rows, 13 column. If you convert it to percentage, this is what? 80-20. Now, I want to view the X test. Now, take a look at the subset of my input variables that will be used as a testing data set. See, row what? 17, 97, 81, 92, the first row. So the rows were not splitted sequentially. They were choosing what? Randomly. That's the effect of that random shape that was set earlier. So now, take a look at the subset of my input variable that we use for training. See, row 36, row 32, row 95, row 108, row 19. So it has chosen it randomly. Okay, the data types, I can check the data types, they are what? I don't need this. Now, I've pre-processed my data set. I've split it into training data set, testing data set, and I've checked the different subsets, and I believe they are okay. So now, I can now choose to use, I'll now move to what? The training aspect. And before I move to the training aspect, I would have determined the particular machine learning algorithm I want to use. So now, I want to start with k-nearest neighbor. I want to give us an assignment, as in those machine learning algorithms. As in, we can go and read about them, so that you understand how they do the prediction, how they work. Now, if I want to use KNN for prediction, this is the syntax. I would have read this somewhere. Please give me a minute. I want to check. Now take a look at this. All the machine learning algorithm I want to use, they are inside this word. KNN I want to use especially is inside this word, neighbors. If I want to use KNN, I will import this word, neighbors. You can see the scikit-learn.neighbors module implements k-nearest neighbor algorithm. If I want to implement k-nearest neighbor algorithm, I will import what? This neighbors module. Now, if I want to implement other algorithms, they will be inside this module. So the KNN algorithm I want to use, I've imported it. This is the syntax for importing it. scikit-learn import. This is the module that we use to implement KNN algorithm. This is the module that we use to implement other algorithms. Hold on, I think, let me just copy this. So now, from this module, this is what my KNN algorithm that I want to use. So I will run this. So you can use the data set I want to use to train my X subset and my Y subset. So I've used this line to train my KNN algorithm, my X subset and my Y subset. I've used them to train my KNN algorithm from that syntax. So now, if I want to make prediction, I'll use this syntax. I'll be using the X test subset as input for the prediction. Where do I want to save the results? Inside this Y predict. So I've used this to display the predicted value. So these are the predicted values. So in 1901, it's predicted that there won't be flood. 1902, 1, there will be flood. 1903, there won't be flood. 1904, there will be flood. So now, I now want to check the actual values in the data set. That is what. So this is the actual values that was used to train my data set. Now this is what the predicted value. So these are the predicted value. So now, I now need to check how accurate is this KNN model. Now, KNN at scikit-learn has different inbuilt performance evaluation metrics that we can use to evaluate the performance of our model. So now, I will import those metrics from this package, scikit package, scikit-learn.metrics. I need what? Accuracy score, recall score, ROC score, and also the confusion matrix. So these are the different performance evaluation metrics I need. So I can import them from these scikit metrics. So now I want to use this to display the accuracy score, the recall score, the ROC score, and the confusion matrix. So now, what was the accuracy score? 91%. So my KNN algorithm was what? 91% accurate. And this is what? This is the confusion matrix. So this is how to use KNN. Now, logistic regression. If I want to use logistic regression, where will I import logistic regression algorithm from? scikit-learn.what? Linear model. I've imported what? Logistic regression algorithm. Now, I want to use standard scalar. I will import it from what? From the preprocessing module. Now, these are what? Another performance evaluation metrics. The cross validation score. Now, this is where I carried out my preprocessing, my scaling on what? On S scale. Now here I have used two preprocessing technique. I've used the min-max scalar, and I've also used this standard scalar for my preprocessing. I can still choose to use one. So now, after preprocessing, this is where I want to set maximum iteration. When I was doing it, it initially gave me an error that I need to set. I should choose the number of time it will iterate. That is the number of time it will carry out the training activity. So I selected 1000. So now, this is where I will now carry out the model training. X scale, this is what? The preprocessed input variable. Now this is what? The Y variable that will be used for training. So this is where I carried out the training. So this is where I computed the different performance metrics. So now, this is the line that will be used to carry out the prediction. Why predict? So now, take a look at the list of predicted values. So now, this logistic regression predicted that there will be flood in all. Yeah. So this is the text value that was used. So I use this to compute the accuracy. So you can now see the accuracy. The accuracy is what? 45%. And you can also agree that it's not that accurate because there was no, it's not as if there is flood in all the year. So I will now see that this logistic regression is not the best for this task.
After doing all these things, now what are you supposed to perform? After doing all this analysis, now looking at it, it's like you are just working, eating that. Are we based on the brief you are giving, maybe the government or whoever gave you the job? People after doing all this analysis, finish everything. From there, of course, we talk about insight. Are we advised them on what to do? To take measures against the flaws that is coming.
Now, what we are doing now is outside the scope of a data analyst. This is the work of a data scientist. Remember the first class. Data scientists are the expert that builds models that could be used for prediction, that could be used for what forecasting. The role of a data analyst is to what? Is to analyze the data and generate insights from it. What we are doing now is what we are trying to see. We are trying to identify a particular machine learning algorithm that could be used for prediction of this particular data set. That is what I'm illustrating. It's just an added knowledge for a data analyst to also be able to build models that could be used for prediction. Now, and you should see that there's a difference between prediction and forecasting. In forecasting, you are predicting future occurrences of a particular thing. Perhaps you can see what we are doing. It's not as if I want to predict if there will be flood in 2019, or if I want to predict the amount of rainfall in 2019. I'm just trying to explore machine learning algorithms that can be used to carry out prediction on this particular data. Now, I already know the years where there was flood. And I want to come up with, and I want to identify a particular machine learning algorithm that will be able to accurately predict what I already know. That is the demonstration I'm doing. So I'm not forecasting. Had it been we want to forecast, that means we want to predict perhaps the amount of rainfall in 2019. Or we want to predict if there will be flood in 2019. But that is not what we are doing. We are not forecasting. We are just trying to examine the algorithms that can be used to predict what we already know based on the data sets we have. So that's what I'm demonstrating. I know you could be interested in forecasting, but that's not it. Yes, you can forecast. So now, if I want to use support vector machine, this is the syntax. I will import it from what? scikit-learn.xvm. So this is the syntax. So now see, I'll still use this to train my model, my support vector machine. Now, see the actual flood values, see the actual, see the predicted flood value. Now, when I carried out an accuracy of my model, I achieved what? 95.83. So now, when I use the logistic regression, I got 45%. When I use this, I got what? 91%. So from this, I can say SVM is more accurate for prediction on this particular data set, because to a great extent it gave me 95% accuracy. So I can also do the same thing with data tree algorithm as well. So it's still the same syntax. I got 100%, so I now try to refresh and start afresh. So let me examine the so this also gave me 95.83 accuracy. So let me see what random forest gave me. Now, this gave me what? This gave me 100% accuracy. Random forest gave me 100% accuracy. And you can see during my explanation, I said, if you compare random forest to Thank you. Now, it is not always smooth. As I've been demonstrating, it is not always smooth. As in, there have been instances whereby you always be errors. An error and it take you days to fix. But now AI has come to the rescue. Now let's see this. Now take a look at this. When I tried to run this, it generated an error. So if you are in this condition, what will you do? Don't call me. And don't freak out. Don't call me. Don't call me. Don't call me and don't freak out. Just go down. And that's the reason why I like using Google Colab. You'll be able to carry out your analysis at a faster rate. PLC is not defined. It will identify the error for you and give you a suggestion on how to fix it. You can see it appears you are trying to use this plot.show function from the matplotlib.py plots module to this. Yes. So that's the reason why before you use AI, it's good for you to have the residual knowledge. So it has informed you that, okay, you've not imported matplotlib.py plots and you want to visualize. So what you need to do is to go and import the module you need for visualization. And the beauty of using this Gemini AI is that it will just stop at telling you the solution. It will also generate the code for you. So this is what I need to add. So now I can copy this and insert it in my code. I can copy this code, or I can use this feature, add code cell. So you can see it has automatically added the code cell for me. Then I'll just run this. It has solved the problem for me. You can see that it has solved the problem for me. So now, let's now assume that I want to carry out a predictive analysis. I want to carry out forecasting. I try to do that on this data set, but this data set is not accurate for forecasting, in the sense that if you want to accurately forecast, you must have the daily data set. Let's say you want to carry out sales forecasting. You must have daily records. You can't use monthly records to forecast, but you can easily use a daily record to forecast. So that is why I couldn't work with this. So now, any task you want to do, you have the basic knowledge. You have a data set you're working with. With confidence, upload your data sets. With confidence, carry out exploratory analysis on your data set. Your data.info, your data.describe, your data.dtype. As you are doing that, the Gemini AI will be gaining understanding of the data set you are working on. When it now comes to the prediction or forecasting, just go to Gemini AI. Give me the code to carry out this prediction. Give me the code to carry out this forecasting. It will generate the code for you. Then you will be able to solve the task. So that's why I've been saying you don't need to cram. But now, as you are running the code, you could be generating, you could be getting some errors. Just go down and go to explain error. It will still explain the error for you and generated. When I was doing all this, when I was preparing the notebook, it took me a whole day. a whole day. As I was using it, I was getting some errors. I was using Gemini AI to correct the errors before I could get this perfect demonstration. It's not something I can come and do in the class. So now, so this is prediction. This is prediction. I want to show us a forecasting task I've once done. You know, we are not the only students. We still have students online. Yeah. Now, this was a project we did. We worked on COVID-19 data. Remember that COVID-19 data set? Yes. So we extracted the data sets for Morocco. Now, what we did here is to now forecast what would have happened. What would have happened in Morocco if COVID-19 vaccine was not discovered as at when it was discovered in Morocco. It's a project we did, we studied the 5 most affected countries in Africa. So Morocco was one of it. Now, how will I start? I started by uploading my data set. Okay, I installed the libraries I need. You can see I use the MIMA scaler for my preprocessing. Okay, I viewed the head of my data set. Okay. Now the columns I want to use now what I did here is not prediction, forecasting. These are the columns I want to use for forecasting. The dates, the total cases, the total deaths, new cases, new deaths, and people vaccinated. Okay, I check for missing values, blah, blah, blah. Okay, at the end of the day, okay, I generated a chart to illustrate people vaccinated, total cases of deaths, and the total cases. Now, these are the total deaths. These are the total cases. You can see that the deaths are more than the cases in Morocco. Okay. Now, we also generated the chart to illustrate the deaths before vaccine and after vaccination. So we used ARIMA model for the forecasting. Now, the reason why we could forecast on this data is because we have daily data of COVID-19 cases in that country. That's the reason why this data set was suitable for forecasting. So we can't use data set that has only monthly values. We need data set that has daily occurrences. So at the end of the day, these are the result of this is the result of the prediction. Now we use this to determine if machine learning algorithm will be perfect for forecasting. A machine learning algorithm that cannot perfectly predict will not perfectly forecast. Now from this, I can see that the actual deaths in blue and the predicted death by ARIMA model was the same. So that's how I know that the ARIMA model is what? Since it's perfect for prediction, to a great extent, it will be perfect for forecasting. From this chart, you can see it's 100% accurate. The prediction is what? 100% accurate. So after that, we now went ahead to carry out what would now be the deaths that would have occurred if COVID-19 vaccine was not generated. So this was the chance we got. COVID-19 deaths in Morocco, actual versus predicted post-vaccination era. So these are the predicted deaths without vaccine. So these are the what predicted forecasted deaths without vaccine. Had it been vaccination was not, this is the point where vaccination was administered, the deaths would have what increased. But because of vaccination that was administered at this point, there was no death. So that's how we can. So if you want we can try out ARIMA model. So now let's assume that I have a task I want to do. Let's say it will be now we are stopping. Yes, we'll soon stop. What you want to do so that you can by your side upload your data sets. That's what I want to demonstrate. Now, upload. Now, okay, let me use. Upload your data sets. Upload your data sets. Carry out exploratory analysis on your data sets. Just go here. Okay, let me run this so that I can understand my data set. So that it's okay. Now I've uploaded my data sets. At this point, I don't know what next to do. Just go to Gemini, based on my data set, generate the code to majorly what Gemini AI, the reason why Gemini AI was integrated into this platform is what generates code for us. So you can see I've uploaded my data set. I don't know what to do. I went to Gemini AI. Based on my data set, generate the code to predict annual flood for me. So it will generate the code for us. Now the reason why I put us through those basics is that when it has generated the code for us, you'll be able to understand what the code means. You can now see from here, I know that what linear regression model was used. You can now see. So I can now copy this code and run it on my environment. If you have any error, click explain error. It will see, give you an idea of what you've done wrong, and it will give you a new code. Then you begin to solve your task. I hope you understand. So you don't need to cram. You don't need to write the code often.
Yeah, that's the sacrifice you have to, as in, to pay on our head. Because we understand. Yes, because we understand. But at the end of the day, when the reason why it's good to use Google Soda is that you can share your, like I've said my file, I don't need everybody. You can also share everything with your colleagues. And more than what you do and you watch it on the same location at the same time. So that is the reason why I can. But now, if you want to edit your code offline, when you download the code, you can still use your Python or this column is used only for data analysis.
It's a Python programming environment. Programming environment. So it's not only limited to data analysis. Last week, I did now. Oh, okay. I will do that. This is it.
If someone misses some of the CS from the exam, what do you do?
I will refer you back to the person handling the processing. Yeah. So we can now go on break. 24 minutes break. 24 minutes. Okay. How can I send you the chat me up? I will send the code the link to you. You're welcome. My friend, my engineer. I'm good though. It won't be long. It won't be long. Yes. Yes. Okay.